Hey, Algebra 1 students, it's Mr. Ford here with another homework tutorial. Today we're looking at 3.2.2, problems 48 through 53, and away we go. If you made it through class at all today and you took away anything, hopefully 348 and 349 are very easy problems for you. All we're really doing here is addressing the topic of area versus the dimensions that are going on in that rectangle. So we're going to find the area of each part and then find the area of the whole. So all you got to do here is multiply the dimensions. 11 times 7 is 77. 8 times 7 is going to be 56. 11 times 3 is 33. And 8 times 3 is going to be 24. So you're just multiplying the different dimensions together to get the area inside. Then you just got to add it all together. I'm going to bring calculator cam up here because we're going to do this because I do not expect anybody to do this by hand. Come on. Who knows what those things are on the top of their heads. I got to zoom in and make calculator cam a little more clear. There you go. 77 plus 56 plus 33 plus 24. Looks like it's 190, and that would be the answer that's there. Easy peasy, monkey cheesy. Okay, let's take a look at the next problem here. It's very similar to what we did today in class. Write the area of the rectangle as right, as a product, and as a sum. So as a product would mean that we know what the dimensions are. So if you're looking along here, you've got 2x plus 4. If you're looking at the dimensions on this, the 2x comes from the two x squared tiles right next to each other, and the 4 comes from the 1, 2, 3, 4 that you've got down below. The other side is going to be x plus 2, since you have, again, an x over on this side, and you have 1, 2 right there. So as a product, you've got, in parentheses, 2x plus 4, in parentheses, x plus 2, just like that. As a sum, you've got, let's see if I'm thinking about this correctly, we have two x squared tiles, so 2x squared. We've got 1, 2, 3, 4, 5, 6, 7, 8 x tiles, 8x. And then we have 8 unit tiles, 2x squared plus 8x plus 8. There you go. 350 is going to take a step back into the algebra world that we are so familiar with. When solving that equation there, Nathan noticed that x is divided by 6. So, I think noticing that, what can he do to both sides of the equation to get x alone? Well, he's got to do the opposite of dividing by 6, and that would be to multiply by 6. Because the opposite of dividing by 6 is to multiply by 6. So, here's how we're going to solve this problem. Let's take the original equation and let's rewrite it down here in this space. Kind of thinking artistically about how we're going to map out our work here. What we're going to do is we're going to multiply everything by 6. On both sides, of course, in order to make it algebraically viable. Over here on the left side, 6 divided by 6, that's actually going to cancel out. 6 divided by 6 is 1, and that's going to leave you with just x. And so whatever is left, it will be the answer. Now, you could use a calculator for 5 over 2 times 6. What I would want you to see as your Algebra 1 teacher is that 6 divided by 2 is 3. And so this is going to be 5 times that 3 that you get from 6 divided by 2. And so the answer is x equals 15 in that case. If you wanted to, on a calculator, you could also do, you could push alpha x to make this fraction, and then do 5 over 2 times 6. And you would also get 15. So whatever you want to do to find that answer. The calculation is not as important to me as the understanding. For the same process for this question, let's start by, again, putting the original problem down here in this space. X over 10 equals 2 over 5. Well, again, we're dividing by 10. So we're going to multiply by 10 on both sides in order to get that answer. Again, the 10s are going to cancel out. 10 divided by 10 becomes just 1, and you have x equals. And now we have 2 times whatever 10 divided by 5 is, which is 2. And that's going to be 2 times 2, which is equal to 4. And there you go. So you really got to think about the process, but then also the execution. There's a couple different things happening here. On the next page, 351, Jamila wants to play a game called Guess My Line. She gives you the following hints. 2 points on my line are 1, 1, and 2, 4. And we're going to find the slope first in question A. What is the slope? Well, you don't need to graph it because you could use the slope formula. It's the change in y divided by the change in x, which in this case would be 4 minus 1 over 2 minus 1. Again, the x's would be represented by the yellows, and the y's are represented by the yellows, and the x's are represented by the greens. 4 minus 1, 2 minus 1. So that is 3 over 1, which is just 3. That would be the slope. Now, if you wanted to graph that, the point 1, 1 would be right there in the grid, and the point 2, 4 would be up here. 2 spots to the right, 4 steps up. And then you could draw a slope triangle that connects those 2 points, and you'd see it's going to be 3 over 1, whatever works for you. As far as the y-intercept of this line, it might be useful to take that same 3 over 1 pattern and go back 1, down 3, and realize you're going to land right there at -2. If you kept that line going, graph the points, and then draw the line, you'll see it cross right there at -2. B equals -2. And then you can write the equation of the line. Y equals 3x minus 2 would be the best way to write that answer. Or you could write 3x plus -2, whatever you want to do. 352 says a calculator manufacturer offers 2 different models of students. The company has sold 10,000 scientific calculators so far and continues to sell 1,500 per month. It has also sold 1,800 graphical models and continues to sell 1,300 each month. I'm going to highlight each of those sentences in a different color because I think it talks about a different kind of calculator. The scientific calculators, and then you have your graphing calculators. And the key question here is, when will the sales of scientific calculators equal the sales of graphical calculators? So whenever you see a word like that, I'll usually bold it to help point it out. But you're going to set these two things equal to each other. So let's write a couple sentences. For our scientific calculators, they have already sold 10,000 of them. And they're going to sell 1,500 per month. Per is a word that needs to jump out at you as a slope or a rate of change. So that's going to be plus 1,500x. We'll say that x is the number of months. That'll be our scientific calculator sentence. The graphing calculator sentence, you've already sold 18,000, and you're going to sell 1,300 more each month. Again, per each. These are telling you this is the slope of the equation. So plus 1,300x right there. And that's our graphic calculator there. And since we want these things to equal each other, we're going to slap a big old equal sign in between them. That's the key to this problem. Really see visually what's happening in the words. From here, it's going to be a straight algebra problem. And I'm pretty sure if I just gave you this problem on its own, it wouldn't be a big deal. So let's just go for it. We'll start by subtracting 1,300x from both sides, because we want to kind of get the x's by themselves. This is kind of like an algebra tiles problem with many, many, many different tiles. These will cancel out. You'll have 10,000. 10,000. I did not give enough room for this problem. Plus 200x equals 18,000. Next, let's get the unit tiles all together. We'll subtract 10,000 from both sides, and then I'll move my work up to the side because I didn't give enough room for this, so I'm going to move it up here. So what's going to happen is the 10,000s will cancel out because they subtract to 0, and what you'll have is 200x equals 8,000, which is what will be left over when you do 18,000 minus 10,000. And now all we're going to do is divide by 200 on both sides to get our final solution. In this case, which I'm going to use the calculator for because I don't know what it is. 8,000 divided by 200, it's going to be 40. And since the unit here is months, so it'll be 40 months. There you go. 353 is the last question here. This is going to be one that if you know how to use the graphing calculator, this will be a very easy problem to do. We're going to make an xy table for this equation, 2x squared minus x minus 3, and then graph the points. I'm just going to do -2, -1, 0, 1, and 2, just to see what's kind of going on in this thing. Now what you could do, I'm going to do most of this on the calculator here, so I'm going to make the calculator cam the forefront here. What you could do is you could go 2 times -2 squared minus -2 minus 3. And I really want you to pay attention to how many parentheses there are here in this equation because I'm plugging in -2. -2 is getting plugged into the equation here for x. That's what's going on there. I'll kind of get them both on the same screen there. Now if I push enter, this is going to tell us 7, and I would write down 7 there. And that's all well and good. But this process can take a long time. I mean, it's not too terrible. 2 times -1 squared minus -1 minus 3. You do have to make sure to plug those numbers in correctly to the calculator. So that could be kind of a pain. The 0 one is actually simple because if you plug in 0, both 2x squared and x become 0, so this becomes negative 3. If you plug in 1, you get 2 times 1 squared minus 1 minus 3. That's negative 2. And if you plug in 2, you get 2 times 2 squared minus 2 minus 3, and that's going to be 3. Right about there. Now, if you know how to use the graphing calculator, this problem can actually be a lot easier, because if you push y equals and clear it out here, whatever's in there, you can just type in 2x squared minus x minus 3, and then push second, and then push the graph button to access the table, and it will actually build a table for you, which you can see the values that we just found right there. So there they are. Once you have that table made, you can go ahead and graph this on that little graph paper that I gave you on this drawing. So I'm just going to slap these points down. Negative 2, 7 won't quite fit on this, but I'll put it up here anyway. Negative 1, 0 is there. 0, negative 3 is there. 1, negative 2 is there. And 2, 3 is there. And you can make that graph kind of happen by connecting those dots. You're going to see a graph look something like this right there. Or you could go on your trusty graphing calculator and just push the graph button. And you might have to play around with the window a little bit, but you should see that same kind of graph happen like that. Kind of a bonus question here is, what are the x and y intercepts? There are 2 x-intercepts. You can see them on the graphing calculator. They are right there at negative 1 and right there at 1.5 or 1.5. You might see them on your graph, x equals negative 1 and x equals 1.5. The y-intercept, there's only one of them. It's right there on the graph. It's at negative 3. And we saw it on our table right here, negative 3. This one went a little longer, but hey, it's still only like 12 minutes long. So hey, I hope you enjoyed it. Have a great time. You guys are awesome. Keep it up. Don't be discouraged, because you are great. And I'll see you in the next video.